Okay. We're going to look at some buffer calculations and some graphs for acids and bases today. Okay, so we're going to work with the system of the acetic acid and water, setting up an equilibrium with the acetate ion and hydronium. Okay, as you know that the Ka is the ion times the hydronium over, that's a 3OOH. Okay. If we take logs of both sides and we rearrange it, we can come up with what is called Henderson-Hasselbalch equation. pH is equal to pK plus the log of the acetate ion over the acid. Right. This is really your conjugate base, and this is your acid. Okay. Now, when your concentration of your conjugate base equals the concentration of your acid, you are what is known at the half equivalence point. So at the half equivalence point, if we were to look at your pH, you are right here, half equivalence point. So you're halfway to neutral. It wouldn't be neutral because it's a weak acid. You're halfway to the equivalence point. All right, but at that point, your pH is equal to your pKa. So if you have a graph and you could read your pH off of it, you can tell what your pKa and your Ka is for an acid. All right, looking at some titrations, you're going to more than likely be asked about indicator colors. So for indicators, you want to choose a indicator. So choose an indicator. Such that the pH at the endpoint, or the equivalence point, is equal to the pK of the indicator. Okay. So you would, given a curve, you want the solution to change color right around that pH at the endpoint. And the pH of the endpoint changes depending on what type of solutions you are titrating. All right, so let's take a quick look at some titration curves, because you should be able to identify these by looking at them. Okay, if I have a strong acid, strong base, my curve will look like this. This will be a pH of about 1. This will be a pH of about 13. This pH at the end point will be 7. That is true for all strong acids, strong base. The curve is the volume, typically of the base added, but it can be the other way. So this definitely is the base added, and this, of course, is your pH on this curve. Okay, if I have a weak acid and a strong base, your pH of 1 is down here. Your pH of about 13 is up here. Your equivalence point, your pH is going to be greater than 7. You should take note of the shape of the curve on this end. Right? This area in here will be your buffered region. That's where you could have a buffer. Okay. And a suitable indicator would have a pK indicator indicator of about 0.6. Okay, and then the last one would be a strong acid with a weak base. You would have a strong acid curve, and then you would wouldn't go all the way up. Your pH here is going to be less than 7. That ends the screencast for acids and bases.